Good evening, everyone. Let's try to go through this review. The first topic is operation with functions, so that's when we're adding functions, multiplying them, composing functions, right? So we're given f of x is equal to x squared plus 9 and g of x is equal to 3x plus 5. And our first job is to add those two functions. See, it says f plus g, so you're just going to add them. When you're adding function, all you do is you take your f function, write it down, plus your g function, write it down. And at this point, you're just looking for like terms. Well, there is no other x squared term, so that's the only one we have. Then we only have one x term, linear term, so 3x. And then I have a 9 and a 5 that are like terms I can combine, plus 14. So my first answer will be x squared plus 3x plus 14. Next, for B, it says it shows multiplication, right? So this time we're going to take them and we're going to multiply. So we need parentheses around those now because we're going to eventually have to FOIL. So x squared plus 9 times 3x plus 5. And now we're just going to multiply through. So x squared times 3x is 3x cubed. X squared times 5 is 5x squared. And then 9 times 3 is 27x. And then 9 times 5 is 45. Once you multiply through, you need to check to see if you have any like terms. And in this case, we do not. We have a cubic, a quadratic, a linear, and a constant. So no like terms. So you can write your answer here. So 3x cubed plus 5x squared plus 27x plus 45. For C, this is a composition, right? You notice how, and by the way, this notation is the same thing as f of g when it's written like that, right? Those two mean the same thing, composition. So what we're doing is we take the g function and we're going to put the g function into x, into the f function. So I'm going to take my g function and I'm going to replace the x into the f function with that g function, okay? So the x here is squared, so we have something squared and then plus 9, right? That will be my f function, but inside I need to put g, so that will be 3x plus 5, wherever the x used to be. And now you just simplify, right? So this is 3x plus 5 squared, meaning multiplied by itself. And then in the back, we still have that plus 9 that we cannot just forget, right? We have to keep tagging it along here. Then we're going to distribute, 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 distribute. So 3x times 3x is 9x squared. 3x times 5 is 15x. 5 times 3x is 15x. 5 times 5 is 25, and then we still have that plus 9 there in the back, okay? At this point, we are looking for like terms. Well, I have two linear terms and two constants, so let's put those together. So we have a 9x squared, 15 plus 15, that will be plus 30x, and then 25 plus 9, that will be plus 34. For D, it is also a composition, but this time we are given a value to evaluate. So those are a little easier. It says, okay, take a 2, put it into your f function. So I'm going to my f function and I'm going to substitute in a 2. So that will be 2 squared plus 9, right? And 2 squared is 4, and 4 plus 9 is 13. So now I take that 13 and I'm going to plug it into the g function. So that will be g of 13. And your g function is 3x plus 5, so that will be 3 times 13 plus 5. And 3 times 13 is 39 plus 5, that will be 44. Notice the difference between C and D. C, we're not given a value to evaluate at, so we just take the whole g function, put it into the f function wherever we have an x. However, for D, we are told to evaluate the composition for x equals 2. So you take the 2, substitute into f for all your x's, find your new value, and now take that new value and substitute in for g. Okay? All right. So B inverse functions. That's the next thing we have to review. So inverse function, if you recall, that's you're going to name the f of x, y first. And at this point, you're just going to switch the x and the y, right? So my y here becomes an x. And what used to be my x is now going to become my y. And now we just have to solve this equation for the new y. So I'm going to multiply by 1 plus y on both sides. And when I multiply that side by y plus y, they will cancel, so I'm just left with a 2. And remember, our goal is to get y by itself, so I have to get rid of that parenthesis so I can get y out. So I have to distribute. And so that will give me an x times 1 is x, plus x times y is xy, and then that's equal to 2. And keep in mind, always keep in mind, think again, what is it that we're trying to do? We're trying to isolate y, so we can subtract x from both sides. And at this point, I want to get y by itself, so I'm going to divide by x on both sides. And there are several ways you could write that, right? We could separate that as two fractions, 2 over x and negative 1, but we can also leave it like that. However, we'd like to see how in the problem we are told this is f inverse of x, so we'd like to label this as being f inverse of x. And we're actually going to go ahead and say this is our answer, right? So f, oh, it's already written down for me. F inverse of x is equal to 2 minus x over x. Then we are told that if the point 2, 0 is on the graph of f inverse, then what is the point or one point that must be on the graph of x? So remember, when we look for an inverse, what we do is we switch x and y, right? Switch x and y. And so since we're given a point and we're told this point is on the inverse, then what point will be on my original function? We'll just take those two and switch them around, right? So it will be the point 0, 2. Just switch x and y, right? Okay. Piecewise functions. So we are given a piecewise function and we have to evaluate all of that. So this looks a little crazy, but it's really not that bad. So square root we're going to keep for now because we don't know what it is yet. 5 times 1, f of negative 2. So we have to look here on our inequality side and say where does negative 2 fit? Negative 2 is between negative 3 and 1. So negative 2 fits in this little chunk of the equation. So that will be, I'm going to write that up here, f of negative 2 will go to this little chunk, so it will be negative 2 times negative 2 plus 1. Negative 2 times negative 2 is a positive 4, 4 plus 1 is 5. So this f of negative 2 becomes a 5, so it will be times 5, and then minus, we have brackets here, and we need to find f of 1. So again, where is the 1? Well, it's not here because that's not or equal to. We have an equal 1 here, so it has to be that. And that's just a 2. There is no function there, so it's just a constant. So no matter what x is, actually when x is 1, the y is 2. So that will become a 2. And then it has been squared. Alright. Then square root of 5 times 5 is the square root of 25, minus 2 squared is 4. The square root of 25 is just 5 minus 4, and then that will be just a 1. So your answer here should be a 1. Alright, number 4, we're going to transform a function. We have to find the following first. So g of negative 2. So if this is my g function, I need to find g of negative 2. Well, that's kind of easy. I'm just going to go to where x equals negative 2, which is going to be right there. And I'm going to read my y value. And my y value will be this one, which is 1, 2, 3, 4. So g of negative 2 is equal to 4. B says find g of 0. Well, g of 0 will be the point here on the origin, and that y value is 0 also. So g of 0 equals 0. Then we need 3 times g of 1 and then minus 2. So let's find g of 1 first. So 1 is here. G of 1 is 1, right? 1, and g of 1 is 1. So we're going to have 3 times g of 1, which we said was 1, and then minus 2. 3 times 1 is 3, minus 2 is 1, so that becomes a 1. The domain, now for the domain, remember it's point most to the left to point most to the right. So this graph actually has an ending point here. It's actually not going to go any more to the left than negative 3. However, negative 3, it's a big old open dot here, right? A big old open circle. So negative 3 is not part of the domain. So we're going to start at negative 3, but not include it. And then on that side, when you have a calculator picture and you don't see anything at the end here, that just means arrow keeps going. So we're going to go to positive infinity. So that's for the domain. And then the range will be the lowest to the highest. Well, the lowest y value we're reaching is a 0. And then the highest, be careful, don't pick this one, because even though this one is growing slowly, eventually it will overtake that y value and keep going to infinity, right? So the range will be the lowest value no matter what. It's going to be y equals 0. And the highest value, well, it's going to keep going to infinity. Transformation, translation of function. So this time we're given a function, and we have to identify the parent function. Well, look at the nature of the function given to you. I have something with a square root there, so my parent function is just going to be the square root of x. Okay? Now I need to describe the transformation from the parent function to this one. So first of all, I have a minus here, and that would mean I am moving to the right by 1. So we're going to say right by 1 unit. So that's for inside. Then on the outside we multiply by 4, so we're going to say vertical stretch by a factor of 4. And then finally we have that little negative in the front here, so you have to remember negative, that's flipping your graph, right? So it's a reflection over the x-axis or horizontal axis, okay? So that's for number 5. Let's go to 6. So on 6, we're looking for function evaluation and understanding, and let's see where you're standing there. So we're given a point 3, 2. This is a point on f, so that's critical to remember, right? The point 3, 2 is on f. We need to find a point that's on negative f of x. So what we want is the f of x stands for a y value, right? You have an x and a y, so it's really going to be an x and an f of x, right, in function notation. And we want a negative of f of x, so we want the opposite of the y. Well, since my y is 2, the opposite of 2 will be negative 2. So the point will be 3, negative 2. Keep the x, right, because we didn't do anything to it. Erase that. The next one, I'm going to have the negative inside. So if you recall, this one is actually going to flip this way, right? So it's going to be symmetrical over the y-axis. So it's affecting the x inside. So this one would actually become -3, +2. Unless I needed to keep that -2, but I don't think so. No, I didn't, because I go back to the original one. C says, okay, now take your f of x and multiply it by 2. So we have to ask ourselves, well, the 3 or the 2? Which one of the one or both of them do we multiply by 2? Well, remember, f of x stands for the y, so only the y is multiplied by 2. So C will actually be equal to the point 3, and 2 times 2, which is 4. For D, it says take your f of x and add 5, meaning take the y value and add 5. So the x is not changing. And then the y value is 2 plus 5 will be 7. E says we are going to add 5 to the x value. So we're really going to move the graph to the left by 5. And I am at 3, and if I move to the left by 5, I would actually end up at -2, right? So let me make sure we're clear on that. So use that. So I'm at the point 3, 2 to start with, right there. And then I want to do a f of x plus 5, meaning I'm going to translate or move my graph to the left by 5. So 1, 2, 3, 4, 5. So at -2, as we said, right? So it should be right there. And the y value has not changed, right? The y value is going to stay true. So the y stays true, and the x will be -2. Then we need to find the inverse. Now remember, when we find an inverse, we take what we have and we switch x and y, switch x and y, switch x and y. So if I have an x and a y point given to me, I just switch them and that's my inverse. So that will be the point 2, 3. There we go. Alright, I think I'm going to stop this video and do a second one, just so it doesn't take forever to upload.